Let's talk about if summations, subtraction and division work for an infinite series of numbers. So I think most of you know that the sum of all the natural numbers is somehow equals to minus 1 by 12. But how? Well, the process was we take another sum, let's solve a 1 minus 1 plus 1 minus 1 plus 1 and so on. So let's say if we end in a minus 1, then all the terms will cancel, giving 0. But if we end in a plus 1, then all the previous terms would have cancelled out, giving 0 plus 1 equals to 1. Since we don't know if it ends in a minus 1 plus 1, so we take the mean value, which is 1 by 2. So this whole thing is equals to 1 by 2. Now let's take another sum. 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. Then we add it again, but we shift the term one step to the right. So it's 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. So if we add these, this becomes 2sb equals to 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. This is equals to SA, whose value is 1 by 2. So 2SB equals to 1 by 2 or SB equals to 1 by 4. Again, let's take the original sum, Sn being 1 plus 2 plus 3 plus 4 and so on. And this, the second B, which is 1 minus 2 plus 3 minus 4 plus and so on. Let's take a few more terms. 6 plus 7 plus 8 minus 5 plus 6 minus 7 plus 8 and so on. And let's actually minus this from that. So this cancel, 0. This minus that is 4. 0 plus 8 plus 12 plus 16 and so on. So the sum becomes 4, taking 4 common, 1 plus 3 plus 4 plus 5 and so on. This is equals to Sn minus Sb equals to. Now here we know that Sb equals to 1 by 4 equals to 4, and this is just the sum of the natural numbers for Sn. We take this to the right hand side. Minus 1 by 4 equals to 4 minus 1 is 3. Then 3 comes down here. So the sum of all natural numbers is minus 1 by 12. Right? Well, here in this step, when we minus two summations of infinite terms, this is of infinite terms. And this is also of infinite terms. And what we're doing here is minusing those infinite terms. So we technically get an infinity minus infinity situation. That's why if we also take the sum of odd numbers, 1 plus 3 plus 5 plus 7 so on, and then minus this but shift it one place to the right, 1 plus 3 plus 5 plus and so on. If you minus that, we get 1 plus 2 plus, so sorry, wrong sum. I mean the sum of square numbers, 1 plus 4 plus 9 plus 16 plus 25 and so on, and minus this from that, and we get 1 plus 4 plus 9 plus 16 and so on. This becomes 0, the sum cancels, 1 plus 3 plus 5 plus 7 plus 9 and so on. This is the sum of the odd numbers. So the sum of odd numbers is 0. But is it though? Even if we are subtracting the same thing, this is still an infinity minus infinity situation, even though the technical infinities are the same. Now let's take the sum, 1 plus 2 plus 3 plus 5 plus so on, or we can just take it as this. So here we can see that an odd number is every one number away and every even number is one number away. So not this one here. So we have that one half of the numbers are odd and the other half are even. Now what if we rearrange this? Let's just say natural numbers. We can also rearrange that 1 comma 3 comma 2 then 5 comma 7 comma 4, 9 comma 11 comma 6, and so on. In this step we see that the even number occurs at every third number from the series. So does that mean 1/3 of the numbers are even? Well, in a natural number, a number is either even or either odd. So how can it be 1/3? Well, what we are simply doing by taking this fraction, just imagine what this fraction represents. What does 1 out of 3 mean? It means just 1 out of the 3 things. One slice of pizza from the 3 total slices of pizza. So here, if you're talking about fractions for infinite sums, we technically are doing infinity by infinity, which is indeterminate. So now the question becomes, do summation and subtractions work for infinite number of sums? As outrageous but technically true things like this emerges from using this sum. Let me know. Thank you.